One. Greetings and welcome, friends. Today, 2.3, geometry, big ideas, postulates and diagrams. We're going to be talking about things that are assumed to be true, and hopefully you'll believe they are true. I don't know, maybe I'll get some pushback on some of these, but we've got these postulates. We should try to familiarize ourselves with these by name. You don't have to know the number. The number is arbitrarily given them based on the book authors, okay? So if you say postulate 2.1, no one doing math on the streets would be in agreement with you. They wouldn't know what you're talking about. But you're like, hey, nice 2-point postulate. And they'll be like, thanks, I appreciate it, right? Everyone would know what you're talking about. So here we go. Point, line, and plane postulates. Remember, postulates are assumed to be true without proof, and these are then kind of the building blocks in which we logically synthesize these things to become new theorems, and we discover more of mathematics within our universe. So, 2-point postulate. Let's see. Hopefully you believe me. Through any 2 points, there exists exactly one line. Okay, I believe it. I believe it. It says 2 points. It is assuming that these points are distinct points, that they are not the same point, because if you have a point, there are infinitely many lines that could pass through that point. So yeah, these are distinct points. That's called the 2-point postulate. You like it. You guys love it. You believe it's true. The line point postulate. A line contains at least 2 points. All right, I think they could have gone for more, but they were just like, hey, I'm only comfortable believing there's 2 points in a line. But yeah, there are infinitely many points in a line. So there we go. The line point postulate. It's okay, don't you worry. The line intersection postulate. If 2 lines intersect, then their intersection is exactly 1 point. There's only 1 point that exists there. A line can't go like woo, woo, right? That would not be a line anymore if it hits another line at more than 1 point. That is a curve. That is not a line by mathematical definition. Even though your line art, when you're doing your drawings for your comic books, which by the way, 3rd grade, Solar Nerds was the name of the comic book that I made. It's pretty amazing. Maybe someday I'll have to publish some of these on my YouTube channel. Just do a reading. That'd be pretty good. Live stream it. I don't know. I'll have to find them in my mom's barn, I guess. So anyways, those are also not copywritten, I guess. So, all right. 1 point only right there. So lines are straight and infinite in both directions on the plane that they exist in. So let's see. 3-point postulate. Through any 3 non-collinear points, so they're not in a line, there exists exactly 1 plane. Interesting. So any 3 points, you could imagine, right, if I connect those dots, I've got like a triangle, and if I move on that triangle's plane infinitely in all of its flat directions, there is 1 plane that passes through those 3 points. Later on in the course, spoiler, we'll discover that through any 3 non-collinear points, there is exactly 1 circle that can be drawn that those points exist on. Interesting. So yeah, exactly 1 plane. The Plane-Point postulate, man, these names are gonna have to work to try to learn some of this vocabulario. A plane contains at least 3 non-collinear points. You can notice kind of some of the symmetry in some of these thoughts. Right, the 2-point postulate was through only 2 points. There's exactly 1 line. 3-point postulate, exactly 1 plane. Right, you can kind of see the building concepts here. And Euclid, the mathematician who a couple thousand more years ago wrote the original 10-chapter text on geometry, these were the postulates that he used. And even though Common Core state standards are all new and wonderful, this book, it's pretty much the same book that Euclid wrote a couple thousand years ago. But math continues to be true. Good stuff. I love it. Reliable, might I point out. Let's see. Plane-point postulate. A plane contains at least 3 non-collinear points. Sure. I believe it. Plane line postulate. Man, we've just got pretty much like all possible combinations of the words points, lines, and planes and the word postulate. You throw them all together, and you got yourself a postulate there, friend. So let's see. If 2 points lie in a plane, then the line containing them lies in the plane. Right? This line that passes through those points can't suddenly just be like, I'm out of here. Woo! Right? Like it can't just like jump off of that plane. No. Nope. It is stuck on that plane infinitely. So yeah, so there's that. And let's see, the plane intersection postulate. If 2 planes intersect, then their intersection is a line. Wow. I love it. I love it. So we have just equipped ourselves with a variety of postulates. Not bad, not bad. And let's do an example, which, like I said, this is unfortunately a vocabulary-heavy lesson. You got it. You got it. I'll go back. I'll go back. Let's see. So also, it's kind of tricky drawing planes. Usually, if you draw a couple parallelograms and then connect some dots, or you could draw kind of like 2 plus signs here in this case, and then just connect the edges. Right, something like that. But yeah, so yeah, we will use these postulates as the basis of geometry, really. And we had to teach you logic, you know, all the law of syllogism and detachment stuff and P implies Q stuff, so that way we are properly building the world of math as we synthesize these ideas. Okay? So let's see. Whoa! I must have undid that. Here we go. Example 1. Identify the postulate using the diagram. All right, it says if, looks like there's 2 lines in this picture, then, there's a point. Does anyone remember the name of that one? Let's see, line intersection postulate. Seems to make sense. Let's see, we'll call it line intersection postulate. Exactly 1 point. Would you believe it? I believe it. Let's see. B, looks like here there's a couple of planes. So if you have 2 planes that intersect, then their intersection is a line. Yeah. Postulate. I'll have to look up the origins of the word postulate myself. Yeah. Let's see. So, all right, here we go. Womp, 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 womp. Also, all of the music that I sing on my YouTube channel are all independently created. False. It's a false statement. I probably hum songs from existing songs that are copywritten. I don't think I've ever had any of my videos copyright claimed or anything like that on YouTube. At least not my math videos. But that's okay. Let's see, use the diagram to write examples of the plane-point postulate and the plane line postulate. So let's see, the plane-point postulate. So let's see, so I've got a plane. Let's see, for this first one, I'll just call that A. I could say that points looks like B, A, and C. Let's see, I don't know, what's that, the Oxford comma? I don't know. I'm just going to write this. Exist on plane. What's the name of this plane here? Is it P? Is it that's probably line N? Yeah. Okay. It looks like they're using like lowercase italicized letters for lines, capital letters for points, and capital. No, those are italicized too. Yeah. We'll call it plane P. We're good. All right. Let's see. Let's try applying the other one, the plane line postulate. Okay. Let's see. I've got to remind myself, guys. It's okay. We might as well start refreshing our memories now. Plane line says if 2 points lie in a plane, then the line containing them lies in the plane. Okay. All right. All right. So if I'm applying that, which line do you think we should talk about? Probably the line formed by AB. we could say that AB, the line, exists in plane P. Looks like. Right? Yeah. Yeah. Let's see. I think I'm good for that example. Ooh, this one's interesting. This is actually a problem from the old blue geometry book, which, even though it's old, it's not as old as Euclid's original. Man, imagine having like a first edition Euclid geometry book. That'd be pretty good. Wow. Let's see. Using postulates and counterexamples, decide whether the statement is true or false. If it is false, give a counterexample. A line can be in more than one plane. What do you guys think? I'm seeing a head nod. I got a thumbs up. Together, that averages to a yes. So I'm going to say true. Yeah, I think if I draw like a little cool box, notice that this line right here exists on both this plane and that plane. All right? You believe it? Seems to make sense. Also, there are, if you imagine these planes rotating about the axis of that line, there are infinitely many planes that line exists in. Let's see, 4 non-collinear points are always coplanar. What are our thoughts? I think it's false. Let's see, let's draw another cool box. Here we go. Man, I so gotta just like do an awesome box drawing tutorial on my YouTube channel. Look how amazing that is. Ooh, look at that. See the dotted lines? I like it. All right, so let's think about some points. Here's A, B, C. All right, those 3 points are on a common plane. Can I think of another point, it's non-collinear, that would not exist on their common plane? Yeah, like this guy over here. I can't draw a line that would, hit all of those. That's somewhat of an optical illusion. A, C, D are not collinear, by the way. Yeah, so here's my counterexample. Bam. Right, something like that. Let's see, 2 non-intersecting lines can be non-coplanar. Whoa. Thoughts? I think that's true. We're going to talk about these types of lines later. Here's line AB, and here's line CD. They do not exist on the same plane, and they will never intersect. Okay? I believe the word for those are going to be skew, skew lines, which I think might show up a little bit later. All right, I like this true or false question. I'm glad I included it from the older book. It's a good question. Oh, wow, I like this. Example 3, let's draw pictures. Diagrams. Because, yeah, this was postulates and diagrams, right? So let's sketch a diagram, friends. All right, sketching a diagram showing TV, the line, intersecting PQ at point W so that TW is congruent to WV. All right, you guys with me on this? I think you're with me. Now, theoretically, there are infinitely many cases of this that we could draw, so don't worry. Let's see. Let's start by drawing a line. Just a happy line right there. Yeah. And if it's going to be line TV, I've got to throw a point T on it for sure, and maybe a point V over here. I like it. Now it intersects PQ at W, so that T to W is equal to W to V. So where does W seem to exist in relation to T and V, if this is true? Could it be here? No. I think PQ is going to be a segment bisector. So let's see. These two segments are going to be congruent. This is our point W. And now I've got to draw an additional segment, PQ. And PQ doesn't necessarily have to be bisected by W. So I'm intentionally drawing it not. Let's see. There's P and there's Q. All right. Something like. And notice this one I did not draw an extending arrow for it being a ray or line. Yeah, just drawing little pictures. That's all we're doing. It's adorable. Ooh, guys, look at this picture. I love it. I'm so excited. Woo! Here we go. Oh, I can still see the couple of pixels of green and purple. Oh, man. Let's scroll down a tad. There we go. All right, a line is a line perpendicular to a plane if and only if, wow, guys, if and only if statements. What does that mean? It's what? What's the word for that statement when it is true both ways? Biconditional. That means P implies Q and Q implies P. All right, so let's see. A line is perpendicular to a plane if and only if the line intersects the plane in a point and is perpendicular to every line in the plane that intersects at that point. Wow, so check out this awesome sketch. So they drew two of the lines that intersect at this point, and notice that it is perpendicular to that one as well as that one, and it is therefore perpendicular to the plane. I like it. This, by the way, would be valuable if I ever wanted to measure the distance of a point, let's say X, the distance of a point to a plane. You should always measure it perpendicular to the plane. I don't know if you have ever measured your own height. Hopefully you measure your height from a point at the top of your head perpendicular to the floor, and not just like, you know, from the top of your head to like the floor 10 feet away from where you're standing. Your results will be exaggerated, right? So yeah, I shouldn't measure, you know, like this if I wanted the distance from a point to that plane. That is, no, I don't think so. All right. So so there we go. Also, this is true biconditionally. So that means if a line is perpendicular to every line in the plane that intersects at that point, then the line is also perpendicular to the plane as a whole. Okay. All right, here we go. Yeah. I feel like I'm not doing as much math when it's so vocabulary driven. But these are the building blocks, friends. Someday we'll put all this to use, don't you worry. Whoa! Crazy sketch. Just follow along. You're not going to have time to draw that. Maybe someday I'll print out some fill-in-the-blank notes for a future generation of geometricians. But it is not this day. Let's see. Which of the following statements cannot be assumed from the diagram? Kind of like the practice we did earlier. Let's see. Points A, B, and F are collinear. A, I'm guessing, is on this line. A, B, and F. I'm saying that's true. So then I'm just going to call this true. It can be assumed from the diagram. Okay. Points E, B, and D are collinear. Where's E? E, B, and D. Oh, they exist on the same plane, but there is no line drawn there. I mean, E could be over here, E could be over there. Yeah, we cannot conclude that. So I guess like this would be one of the statements that cannot be assumed. I'm just going to call it false. Let's see. AB is perpendicular to plane S. All right, plane S is this plane. Where's AB at? AB, it's perpendicular. Oh, it's labeled perpendicular. Notice that this edge of the little square didn't have like another segment that it was connected to. That means they're just referring to perpendicular to the plane itself. Yeah. I was actually listening to a Dungeons and Dragons podcast this morning on the ride into work. It's pretty great. The characters, they just entered the plane of Mechanos, which is like a mechanical plane that somehow kept the universe functioning. It was somewhat amusing. But there you go. Don't you worry. I could do a shout out and give their name, but I'll let you guys figure it out on your own. let's see, CD is, the line is perpendicular to plane T. CD, the line, perpendicular to plane T. I don't know that it's perpendicular to the intersection between those planes or any other line on that plane. Actually, I wonder, that'd be an interesting thing to prove. There must exist one line on that plane that it would be perpendicular to. I think that would be true. Someday maybe we'll try to prove that, but that cannot be assumed. AF intersects BC at point B. AF intersects BC at point B. True. Absolutely true. All right, so, all right, I think we're good. I think I'm calling it. So notice I didn't do a lot of like number crunching or like rearranging or algebra or angle finding. This is just like familiarizing ourselves with these postulates and these diagrams. Really. And I mean, really, that is kind of what they promised us. Postulates and diagrams. And I think they delivered. Well done, big ideas. Well done. All right. Wow. All right. There we go. Have a great day, internet friends.